Alright, so another way to solve a system is by using what's famously known as elimination. Once you catch the hang of this method, it's very easy, it's very quick. Students tend to love it because of that, but the one thing I'll say about this is this only works for linear systems. If you're dealing with a system that's not linear, elimination does not work anymore. So make sure you understand the substitution technique, all right, especially when you see what's coming, because you're like, oh, elimination is great, I'm going to use this. Okay, you can, but again, don't forget, it doesn't work all the time. All right, so know both, and actually know all three: visually, substitution, and elimination. So what's elimination look like? Well, again, what I'll do is I'll solve this system. Getting a little messy here. Let me rewrite the system that we're solving by using elimination, and what I'll do is kind of do a step-by-step procedure. For step one, what you have to do is figure out, you have to make a decision again. So it's very decide which variable to eliminate. And that's different than substituting, right? Because here it looks like we eliminated the y, but I accomplished it by substituting. We're going to do an elimination completely different. And so once you make that decision, let me think about the next step here. What you want to do is you want to use the multiplication property of equality to make sure the coefficients that I'm dealing with are opposites. And sometimes we're lucky and it's already there. So for example, let's take a look at our system and let's say we want to eliminate y. Well, when I look at y, I already have step 2 because the coefficient for y up here is 1 and the coefficient down here is -1. So those are already opposites. So we're good to go to step 3, right? Once you go to step 3, you basically combine like terms in your system. So when I do that here, right, x and 2x gives us 3x, y and -y cancel out, and 3 and -6 leaves us with -3. And then divide both sides by 3, right? That's step 4. You can now solve for remaining variable. All right, and in this case what we get is x equals -1. All right, and then you now at step 5 you have a choice. You can redo the elimination technique, or you can take this value and plug it in and find it that way. Since we're learning elimination, I'm going to do that. So let me rewrite our system here. All right, and this time what I'm going to do is eliminate the x. Okay, so there's my decision. I'm going to eliminate x. So what's my next move? Well, I have to use the multiplication of property of equality, which says I can multiply both sides by anything I want, right, and maintain the equality. But I'm going to do it in such a way that the coefficients are opposites. So right now the coefficient here is 1, right, and the coefficient here is 2. They're definitely not opposites. But what I can do is take this function and multiply both sides by -2. Right? That's going to create a new situation. We get -2x minus 2y equals -6. And of course the second equation I never touched. All right? And so now what I can do is step 3, which is combine like terms. My x's go away as planned. -2y minus y is a -3y, and -6 combined with -6 is -12. Solve for the remaining variable, step 4. So I'll do this by dividing both sides by 3, and lo and behold, what I get is the same ordered pair that we got twice over, right, visually and with substitution. Of course, step 6 here is to check and make sure that your thing works, and we already know that it works. In practice, you plug it in and see that it works there. Right? So that is elimination. So I know that was really quick. I just kind of wanted you guys to see all 3 techniques on one page so you can kind of compare and contrast and see how they're different. Right? Obviously, this visual one is extremely different. Substitution and elimination are kind of similar, but the way we approach it are very different. All right? We're eliminating a variable up here by making a substitution. Here we're eliminating a variable by using our multiplication property of equality to force coefficients to be opposites. Combine like terms and we're done. So yes, this is fast, right? And it's really cool, but it only works for linear systems, right? Substitution, a little labor intensive, but it does in fact work all the time. So this is actually a stronger method, even though that's so fast. Okay, so there they all are. We'll spend the rest of our module basically taking a look at each one of these, with the exception of the graph. I think you guys understand the graph thing. It's this part that's new. So we'll focus on substitution elimination techniques for 2x2 and 3x3 systems and just practice doing that. So that's what you're going to see in some videos coming real soon.